I want to talk now about velocity and speed. So we've already introduced position. Position is your location, for example, along a number line where you've marked all the positions by numbers. And we talked about you could change your position, that corresponds to a displacement where you can find the change, the like if there's an x variable that defines the number that corresponds to a position, you can find the difference of those numbers. That's a displacement, and the sign can give you direction information. The absolute value was the distance. All right, so that's all well and good. Now, what if in addition to talking about movement along a line, you also wanted to talk about, well, how fast is something moving along the line? Okay, so let's get back to, let's make a number line. And we already know what displacement is. And if we want to know how fast, there's going to be a ratio that's going to give us information to answer that question. Okay, and I'm going to use the delta, the triangle notation to describe what I'm talking about. So to say how, let's first have somebody that starts at the origin, starts at 0, and starts running to the right. Okay, so if he was to, well, first the velocity, what I mean by velocity is the ratio of the displacement by how long, the change in time, mind you, it takes in order to accomplish that displacement. All right? And velocity is sometimes denoted by the variable v, and the units are the units of displacement and change in time. So the units would be meters per second in SI, International System Units. Okay, so let's say that in 2 seconds the person reached the position 3. All right, so we would say that the displacement was the difference in the positions, 3 minus 0, and I said it took 2 seconds, so the velocity would be 3 over 2, or 1.5 meters per second. Okay, now velocity can be negative. All right, if the person was, let's say, let's do an example of, let me make another person. Let's say I had somebody on -2, and it took them 10 seconds to get to the -3, so they weren't as fast. All right, so just go with me on this one. So let's calculate the velocity for that. So I'll do this in the upper left. So the displacement was final position minus initial, which that gives -1, and the time difference I said was 10 seconds. All right, so putting all that together, the ratio is -1 over 10, or minus 0.1 meters per second. Okay, now when we remember when we talked about displacement, and sometimes you want the minus sign and sometimes you don't. So when you only care about the number, and you want it to, when you want to think about a positive number, we use the word distance, and that was the absolute value of the displacement. But if we want direction information, then we use displacement. Okay, now with velocity we have a similar idea. If you just want the number, if you just want the absolute value, then, and you don't care about whether the velocity is positive or negative, then, well, you're talking about something a little bit different. That's called speed. Okay, speed, and that's the formula will use the absolute value. Excuse me, change in x, not v. All right, so that's all. So for example, for the first problem that I did, we would say that the speed is 1.5. For the last example, even though the velocity was -0.1, we would say that the speed is positive 0.1. Okay, and your car, we call the instrument that tells you how fast you're going down the freeway, we call that a speedometer. That always gives you a positive value, right? Nobody ever says I'm driving negative 65 miles per hour on the freeway. All right, so that's an example where we care only about speed.